Welcome to the Faculty of Mathematics International Women in Math Day celebration. We're so happy that you guys could join us today. I wanted to welcome everyone here for this virtual conference that we're having, and we're really happy to have you here for our virtual coffee session with our Canada 150 Chair in Mathematical Biology and Medicine, Anita Layton. My name is Katie McMullen, and I'm the Development Officer with the Faculty of Math at the University of Waterloo. And before we get started today, it's my pleasure to share with you a message in recognition of this very special day from the Right Honourable Justin Trudeau, Prime Minister of Canada.
Hello everyone, bonjour à toutes et à tous, and welcome to the 2020 virtual Women in Math celebration. A big thank you to the University of Waterloo's Faculty of Mathematics for bringing everyone together virtually to mark the second International Women in Mathematics Day. And to everyone taking part across the country and around the world, thank you for coming together to celebrate women in math. Now, more than ever, we need your leadership to tackle the biggest challenges we face as a world, from beating this pandemic to fighting climate change to building stronger, more inclusive communities. Malheureusement, les femmes sont encore sous-représentées dans le domaine des sciences, de la technologie, du génie et des mathématiques. C'est inacceptable. Il est temps pour nous tous d'éliminer les obstacles que doivent surmonter les femmes et de faire en sorte que vous ayez les outils et le soutien nécessaires pour réussir. Et c'est exactement ce que celles et ceux qui participent aux discussions d'aujourd'hui nous aident à faire. So today, ask tough questions, learn from each other, and celebrate each other's achievements. Many of you are already blazing a trail in research and business, and you're inspiring the next generation of female mathematicians. Have a great virtual conference, and I can't wait to see what you do next, and I can't wait to see the hashtag #IamGoodAtMath trending. Encore une fois, merci.
I am pleased to introduce our moderator and co-speaker for this session, Dr. Charmaine Dean. She's the Vice President of Research and International at the University of Waterloo. From 2011 to 2017, Dr. Dean served as the Dean of Science at Western University. Prior to her service at Western, she played a major role in establishing the Faculty of Health Sciences at Simon Fraser University in her capacity as Associate Dean of that faculty. Previously, she was the founding chair of the Department of Statistics and Actuarial Sciences at Simon Fraser. She's an engaged board member of several relevant boards, including Compute Ontario, the Southern Ontario Smart Computing Innovation Summit, the Vector Institute for Artificial Intelligence, and the Institute for Cybersecurity and Privacy. Dr. Dean has also served as a board member for the U.S. National Institute of Statistical Sciences, the National Institute for Complex Data Structures, and the Canadian Statistical Sciences Institute. She is dedicated to developing outstanding computing capabilities for researchers and for building capacity in Canada, and is interested in bringing together diverse communities to drive forward a unified direction for data management activities and priorities. So thank you so much for being here with us, Charmaine. I'll hand things over to you.
And I think you forgot one important thing in the introduction. I graduated from the Faculty of Mathematics at the University of Waterloo. So
maybe the most important part.
Yeah, that's right. It is my pleasure to introduce Anita Layton. Anita is our very special guest for this session. Anita is the Canada 150 Research Chair in Mathematical Biology and Medicine. And she is a professor of applied mathematics, computer science, pharmacy, and biology at the University of Waterloo. Being a research chair means that she has more time to devote to research. And in celebration of Canada 150, the Government of Canada awarded institutions throughout the country special chairs that were called Canada 150 chairs. And we are so thrilled that Anita was one of the ones that was awarded, and we're very happy to have her at the institution. Anita's research focuses on diseases that are really important to her personally because they actually run in her family: diabetes and high blood pressure. She and her students use mathematics as a microscope to understand how these diseases affect us. They build computer models to simulate the effects of new drugs that have been developed to treat these diseases. And one of her research focuses is to understand how different drugs affect different people in different ways, and particular men and women. For instance, there are major differences in how men and women control their blood pressure. But patients with blood pressure are often prescribed the same medicine, not necessarily taking into account personalized treatment. A major focus of Anita's research has been to use mathematics to better understand what drugs work best for women versus men. And she's a very strong advocate of personalized medicine. With the pandemic, Anita has pivoted. Many of us are trying to understand how to get us out of the current challenges, and Anita and her team are foremost in that direction. She and her students have refocused their effort on modeling how we get infected with COVID-19, what the risk factors are, what drugs are most effective for you, given all the other illnesses that an individual might have. Anita is not just a leading researcher. When she first arrived here, she told me that she was very interested in supporting some major files at the office. And I told her, not in the least bit, she needed to focus on her research. That's what she was, a research chair. But she pounded away at my door. And now she is also the Associate Dean, Research and International in the Faculty of Mathematics. What that means is that she helps all the researchers in the Faculty of Mathematics with their research needs. She tries to support them, tries to provide them opportunities to obtain funding. She helps them with their grant proposals. She devotes a lot of time and energy towards service for her community in mathematics. As well, she is the Research, Equity, Diversity, and Inclusion Council Chair for the whole of the institution. So that means that she has a strong lens on research, equity, diversity, and inclusion, that she keeps me on my toes to make sure that I also have this as a strong focus, which I do, but Anita makes sure that I do with a whip at my back. And she and I work hand in glove to make sure that we support the community of women, not just in mathematics, but at the institution broadly in being successful. Anita, really look forward to having this conversation with you this morning. Thank you so much for being here and joining us.
Thank you, Charmaine.
So I wanted to start, Anita, by telling us, how did you get here? Could you tell us a little bit about how did you end up in mathematics?
Oh, okay, sure. Good morning. Thank you, Charmaine, and hello, everyone. I would love to tell you about my personal journey and how I ended up in mathematics. So I can say that I have like a love-hate relationship with mathematics. So I grew up not here in North America. I grew up in Hong Kong. And that is relevant because over there, kids can go to the same school from kindergarten all the way up to high school. And I went to such a school, started in pre-kindergarten when I was like 4 and stayed until I finished 12th grade. So my father was the head of the high school math program. So my dad, Mr. Tim, was very much loved and respected. So I remember being a young girl, going to the school's staff family events with my parents, at Chinese New Year, Mid-Autumn Festival, Christmas and such. Some of the other school teachers would, pat me on the head and say, "Oh, Anita, you're so smart. You're going to grow up to be a math teacher, just like your dad." And of course, I thought, right, I don't think so. Math is going to be the last thing I'm going to do. So fast forward to college, I started out being a physics major because, I like learning how things work, and there's lots of math without being a math degree. So it's like perfecto. But then I realized that I'm too clumsy to do experiments. So Charmaine, you remember we had that virtual lunch together. So it was a good thing you didn't eat with me in person, because otherwise I probably would have knocked over your drink or something. So basically, any experiment that I did, I would manage to mess it up. So I wisely switched to computer science because, there, if you mess up, there is no explosion, it doesn't smell, and nobody has to know. So I got a double major in physics and computer science from Duke University. And then I went on to get a PhD in computer science from the University of Toronto. So I don't have a math degree at all. Well, I haven't told you how that I ended up in math. Well, my PhD thesis in computer science wasn't about like AI or computer graphics. It's about how to numerically compute solutions to equations that describe our weather system, our crazy weather system. So it is really mathy. So once I got my degree and began looking for jobs, I realized that I fit much better in the math department. So I got a job at Duke University in the US. And so here I am, a math professor without a math degree.
Very nice. You know, physics and computer science, as you were going through that historical viewpoint, physics and computer science go really well together with climate models. So I was wondering when the climate side would come in, and obviously it did for you as well. What about coming to Canada? So we know why we chose you, Anita. You know, we looked at your CV and we decided straight off the bat, this is a woman that we wanted here. What about you? Why did you decide that you were going to accept the Canada 150 chair?
So after I got my PhD, I ended up in the States, and I got a job in the math department at Duke University, North Carolina. I started out as an assistant professor there, got tenure, got promoted, and, spent 15, 16 years there. So I was there for a long time, and I was really happy there. Then Canada came calling, right? So I was offered a chair. And I very, very happily accepted it and came to Canada because number one, I saw an opportunity to expand my research program. And number two, because of the really, truly outstanding research environment that I see at Waterloo. And also, I'm a proud Canadian, so it's really great to come home. So I came to Waterloo in fall of 2018. So it's been more than a year and a half. And I would have to say that the support that I've gotten here is truly amazing. The students are outstanding, and Canadians seem to have a much better sense of equity. So I have so much support for any equity-related initiative that I want to take on. I love working with you, and really want to thank your office for the support, truly, Charmaine. And so basically in Waterloo, I get to do the research that I love, promote equity with all the support that I have never dreamed of, and I truly love every single moment here.
Anita, that's fabulous. And we love having you here too. I wonder if you could tell us about the road and the path and how rocky it was. And maybe not just for you, but what do you think are some barriers right now for women in mathematics? And so your personal journey, but also maybe just generally, what do you think are barriers facing? And we've got a range in the audience, as you know, from high school students to individuals who are just starting their career to more seasoned individuals that perhaps we'll hear from. Tell us in that perspective with a whole range of career stages listening in, what do you see as barriers?
Yeah, sure. So generally speaking, I would say the lack of female role models would be the biggest barrier to achieving like gender equity in math or in STEM in general. And it actually starts way before college. So let me tell you a story that stars my son. Okay, so my son is 13. He's sleeping upstairs because he's a teenager, and he wouldn't wake till maybe around 1 p.m. when I wake him and his sister for lunch. So he's right now super into computer animation. A story I'm going to tell you took place a number of years ago when he was maybe 5 or 6. So one day he came to me and say, "Mommy, I don't think I'll ever get married." I was like, well, that's not good because I want some grandkids at some point. So I was like, okay, why is that, sweetie? And he said, well, because there are no girls in electrical engineering. Okay, so remember he was 5 or 6. So he was a little boy and he didn't really know the word electrical engineering. But he described what he wanted to do when he grew up. And yeah, it was electrical engineering, clearly. So I was shocked. I mean, this is my son. So how did my own son get this crazy idea that women engineers didn't exist, right? So whatever have I done? So, but then I thought about it and I realized perhaps I shouldn't have been so surprised. So at the time when he was, 5 or 6, my son's favorite TV show was Phineas and Ferb. Okay, so I don't know if everybody here is familiar with Phineas and Ferb. It is a TV show, very, very creative TV show. It follows the adventures of two brothers, Phineas and Ferb, on their summer vacation. Okay, so every day they would embark on some grand new projects. One day they will build the biggest and bestest roller coaster. Another day they will build this machine that interprets animal languages or baby languages, and they do a lot of cool things. So these boys are extremely creative. And there is also this crazy scientist in there, Dr. Smurf, who has all kinds of crazy evil schemes. So who is this Dr. Smurf? So he's this middle-aged white dude with crazy hair and glasses. So are the girls in the show you might want to know? Oh yes, there is Isabella. What does she do? Well, she has this big crush on Phineas, and all I can remember her doing is, dancing and saying, oh, what you doing, what you doing? So this is my son's favorite show, and these are his role models. So no wonder it never occurs to him that girls can invent and engineer things. So since then, I made it a point to introduce my son to many of my engineering girlfriends. So that particular misconception was resolved. But I mean, you and I and everybody here know how widespread this stereotype is, right? So when I fly, I should say flew because, flying, getting on an airplane is such like a lifetime ago, right? So when I fly, sometimes I would chat up the passenger sitting next to me because, I want to be friendly. And inevitably, some of them would ask me, so what do you do? And I would say, well, take a guess. Nobody ever guess math professor. Okay, so sometimes I would give them a hint that, oh, I teach at the university. And they would say, oh, are you an English professor? I would like, seriously, English professor? You don't notice my accent? So at least I got my little boy straightened out, but that doesn't change the fact that I don't look like a math professor. Right. So what does a stereotypical math professor look like? Well, probably someone, I don't know, I hate to say this, but someone who has no friends and no life outside of his or her office, maybe cannot carry on an interesting conversation if it is not about math. So these stereotypes are not positive. They are actually, I would say, horrible. I mean, who wants to be that person? I definitely don't. So I would say the lack of good female models in mathematics and the negative stereotypes are the major barriers.
Mm-hmm. That's good, Anita. But Anita, I don't know if I can carry out a good conversation if it's not about math. So I'm not so sure how some of the characteristics that you portrayed actually fit with me. I completely agree with you. Despite so many good intentions and so many interventions by leaders in higher education, women are still seriously underrepresented, not just in mathematics, but I'd say if we think about our leadership roles also from the leadership perspective, we're very lucky at the institution at the University of Waterloo with so many initiatives, with a dedicated leader, a president who's put in place some extremely superb initiatives related to women generally, and also in your faculty, women in mathematics. I'd say that we're fortunate, but I would say that generally that both absolutely and relatively in terms of the pool of candidates available, the number of women in leadership positions is definitely not representative and very, very small. And I'd also say going all the way back now, of course, I am a lot older than you are, but when I first walked into my faculty meeting, actually, when I was, I think, day 3 on the job and standing in front of a photocopier, I remember one of my male colleagues standing next to me and plunking a a bunch of exams down and saying, hey, listen, could you also photocopy these for me too? Thinking that I was the new receptionist in the mathematics department. And then having to be introduced as, no, I'm actually the new professor in the mathematics department, because a lot of the faculty members there didn't have any role models. I was the first professor in that department. And I would say that when I was growing up as well as an academic, there were 200 full professors, and I was the only full professor, female full professor. So I agree with you that it's completely tough without role models. I have had the benefit of having some amazing female role model leaders who have been just exceptional, you know, in terms of leadership and in terms of support that they have provided. So I have had that benefit. I hope that you and I are providing that benefit for the individuals at the University of Waterloo as well. And if we're not, then we're open to it. Make sure that everybody who's from our institution, you're all aware that this is a prime role for both of us, and we're happy to support you. I also wanted to talk about the family side, Anita. A lot of the young women are interested in trying to balance work and family, and that's also been quite difficult. So in terms of barriers, we talk about role models, but there's also bringing up kids. You know, when I had my first son, I think that there was a good 3-year gap in productivity for me. I was at home. I was doing a lot of work nursing. We didn't have maternity leave at that time. So a lot of my work as a grad student was done at home, but I had to keep things going. I wondered if you could talk a little bit about the whole family and handling issues related to the family, and there's also at the other end of the age spectrum, taking care of older parents. So any thoughts about that and how that impacts men and women differentially, and women in mathematics?
So I have 2 children, and they are relatively older now. So my son, as I said, is 13, and my daughter is 16. She's actually taking AP Calc this afternoon at 1:30 p.m. online. So good luck to her. So I had my daughter when I was a postdoc at the University of North Carolina at Chapel Hill. So at the time, I felt like I need to keep working. So it was very important to me that my productivity isn't affected at all. And I feel like, you know, that's what is expected of me. I remember when I was pregnant, walking around, people would ask me, so are you coming back to work? And I found it interesting that nobody asked my husband whether he's coming back to work. You know, I mean, that's his child too, last I checked. So I was a postdoc, so there was no maternity leave to speak of. And I don't know whether, I mean, at the time I was younger, so I didn't really understand, you know, what work-life balance is. To me, is work. So I was writing grant proposal till the day, I think, 2 days before I went to the hospital to have my child. And when I came back, I kept working. So that's what it was for me. About how long ago later? About 3.5 years later, I had my son, and I was an assistant professor at Duke then. And then I think the expectation of keep working was even harder. I was kind of like you. I was the only tenure track female faculty in the math department at the time. Actually, I was the only one for quite a few years. So I'm not sure everybody else understand, you know, what it is to have a family. I was lucky because my children, I would say, are relatively, so we say, low maintenance as kids. They somehow don't tend to get sick, and they weren't very demanding. So I realized it's not like that for everybody. So like working from home now, right? So look at me, I can just Zoom Why is that? Because I have teenagers. They don't really need me. They just want to see me at mealtime. So I make lunch and dinner for them. Do I need to homeschool them? Not really. My daughter is 16. She learned AP Cal all on her own, not even taking a class at school. My son, he's 13, so he needs some guidance. You know what guidance I told him? I sent him a link to Khan Academy and say, go learn something there. That's the extent of homeschooling I have given my children because I've got a job. I realize it's not like that for everybody. I mean, I have friends who are younger, who have younger children, and I think they have a much tougher time. And I remember seeing this meme, right, that says, oh, look what you can accomplish. Like, this is Newton, and he invented calculus when he was stuck at home. I don't know whether that's true, maybe it was. And I was like, I mean, this meme like annoys me to no end. I was like, okay, sure, you can invent calculus if you don't have to do house chore, if you have no children to take care of, or you don't have to wake up at midnight so you get a really good time slot for your Instacart order. So work-life balance is important. I think I realized that when I'm older, and you know, we just have to do the best we can, and don't be afraid to ask for support around you.
Mm-hmm. I think you're right. Asking for support is really helpful. I'd like to add a few reflections to that, Anita. So with my first child, I spent a lot of time playing, cleaning up toys, nursing, etc. So although it was at the end of my PhD thesis, I would say there was a bit of a difficult period on a rocky start, and then recovered from that. And then with my second son, I spent a lot of time with my second son. You look at my CV, there's a clear gap in publications and productivity related to the birth of my second son. But for me, that it was really important to spend time and to be there and to be a strong mother and to support, etc. And I think a lot of people have difficulty afterwards with this, but I didn't. Picking up the ball afterwards wasn't a problem. And pushing through and thriving afterwards. I think that it did take some work, but it was not as difficult as one would have imagined. And then after a couple of years, just escalate the trajectory almost immediately. So I'd say that it's really important to do what you feel is critical for your own personal tastes and development. And if that means that you want to take a break and spend some time with your children so that you can develop them in ways that they need, or if they have special care, then I don't think it is insurmountable recovering from that as your children get older. And I know I was at the stage where kids were teenagers. I agree with you completely. When they're teenagers, it's a lot of hands off. In fact, it's a lot of effort to get into the door. They are becoming independent and wanting to have their space, and so that's a really wonderful time when your career can then become a little bit more central in a person's life. Anita, I wonder if you would talk a little bit about your title is a mouthful. Mathematics, computer science, pharmacy, and biology. Of course, it touches on all the variety of areas that you work on, and you're a researcher in mathematical biology. So these areas obviously make a lot of sense. But could you tell us a little bit about what you see as success in this field? Mathematics is so broad and diverse, and there's so many different applications, and it has such a wide reach. What do you think? What do you think that success? What does success mean for you?
Okay. So first, let me ask all our participants to think about this question with us. Right? So, what does success mean to you? Okay. On the count of 1, 2. Probably there's no one size fits all answer. So, one person in general for a career may define success as not having to work more than 40 hours a week. Another person might define success as having $1 million in the bank. And we academics tend to think in terms of promotion, awards, and such. So for me, success is all of the above. Actually, just kidding. So for success is really doing what you truly love. So I love my job. I love research. Every day I get to spend hours trying to understand how things work in biology. I like asking questions, and I like answering questions even more. So you know what else I get to do? I get to learn something new every day. So often my grad students would come tell me that, oh, they came across this really cool paper, or they just finished taking this awesome online course. And you know what I would tell them? I say, oh, great, you learned something that I don't know. Now come teach me. And bless their heart, they actually would. So I love my research group. And as you said earlier, I'm also the Associate Dean for Research in the math faculty. So, like you, at first, I wasn't sure about taking on the administrative role because, it does take time for my research. I'm supposed to spend all my time in my research. But then I realized what that job is. So it is to help my colleagues with their research programs. And I'm given resources to help people. How cool is that? So I love that job too. And then I get to spend part of my time promoting equity and diversity. And that has always been my passion. And honestly, I've never had the kind of support that I now enjoy at Waterloo. So I love working with you. I love working with other members in the Research Equity Council. So yeah, I love what I do. I love learning something new every day. I love doing things that I find exciting, doing things that I believe in. And I basically got paid to do, what makes me really, really happy. So if that isn't success, I don't know what is.
Mm-hmm. That's great. As you know, Anita, I work in analytics. And I started off working in the health field, being a biostatistician. So a lot of linkage with what you're doing. And even right now, we're doing some modeling, COVID modeling and pandemic modeling as well. But the opportunities in analytics to be working with the most brilliant scientists from a whole variety of fields, that for me is really interesting and makes work very successful. So I've been working in forestry when the forest fire scientists needed some analytical help. And then now again, joined you in pivoting to pandemic. Let's talk a little bit about that. So you've been able to be adaptive and to react really quickly to the needs of society, and particularly with COVID right now. Could you tell us a little bit about that, how you were able to persuade your students? What made you think about pivoting to COVID research? How is it going? Could you speak a little bit about? Mm-hmm.
So I don't think my students need convincing or persuading at all. So, COVID's been amazing, right? So it has this unifying effect on the scientific community. So, our political leaders have locked their borders, but scientists actually have been shattering our borders and creating a global collaboration like, nothing that we have seen before in history. We have so many experts in so many different fields, in so many countries, focusing simultaneously on one topic and with tons of urgency. So personally, I feel really fortunate, right? My life hasn't stopped because of COVID. I haven't gotten sick yet. My two children are doing fine. I can work relatively easily off campus. But when I look around, I see that many others are not so fortunate. 5,000 Canadians have died, and we have 285,000 deaths in the world, and many, many, many more have gotten sick. So even if you manage to stay healthy, many of my non-academic friends have lost their job. So I want to do something to help. Now, I already explained to you that I cannot do labs, so I cannot make a vaccine, but I know how to do drug simulations. I know something about how our bodies work. So my students and I started modeling COVID-19 infection about how the virus evades and interacts with our immune system. And how if you have heart disease and take certain medications, it might actually increase the likelihood that you will get really, really sick from COVID-19. So a grad student and I had this marathon week where we spent essentially, no joke, 20 hours a day working on a COVID project. So we dug through literature, wrote computer code, did simulations, analyzed results, and we're actually able to finish a paper in a week. So that was so much fun. Oh, but then I also realized that I am too old to go the whole week with so little sleep. But it was exhilarating. I would totally do it again in a heartbeat.
Mm-hmm. You know, everybody's working so hard. Thank you so much, Anita, for thinking about how you could transform what you do to shed some light on this. I mean, we obviously know about immune compromised individuals, but to understand other complicating factors, all of that is wide open research. So very good to have you put some effort into this space. And actually, I'm very interested in profiling some of your work. Once we get off this call, we'll talk about that, how we can make sure that that's brought to the attention of those who are working with individuals with certain kinds of complicating factors. I have a few other questions, but we have a lineup of questions from the audience, Anita. So I think, why don't we pivot a little bit from my questions to you to some questions from the audience, and they won't be necessarily in a particular flow or thematic area. They'll be coming from all angles. So the first one, Anita, is could you describe, this question is actually for me, but I'm going to let you take it. It's about what are the equity initiatives that we're involved in at the institution. Could you shed some light on that for the audience?
So I think you and I are involved in equity initiative at various levels. At the student levels, and I'm involved in the Women in Math, part of committee that is part of the Faculty of Mathematics. So we organize events for students, undergrad, graduate students, networking events and such. The Research Equity, Diversity and Inclusion Council that we all work on together. We try to promote research equity among the faculty, hook them up to research funding, especially the women faculty, organize a panel to showcase female leaders in the university. And we have events, seminar for women leader to promote equity in the research landscape at Waterloo.
So Anita, we also have focus group discussions with women leaders at the institution to understand challenges. Like, we bring young faculty members and more senior faculty members at the table, I think once every 2 months, to talk about what are the challenges they face in a very safe environment, and then work towards helping them overcome or mitigate some of these challenges. But sometimes it's just the networking that supports them, but sometimes it is an intervention at a high level, either you or I bringing it to the attention of the dean or the chair, and then helping to resolve issues. We also host some major events for women. I mean, this is one of them, but we also host some major events for women at the institution in specific areas as a whole. And we support individuals going out and getting leadership training. So we provide some financial support for individuals who are interested in understanding how they can do better. We have what's called an equity action plan that is posted at our website at the institution. And I can provide Katie afterwards with the link to that website. And a wonderful staff member who is open to hearing what else needs to be done in terms of driving equity initiatives forward at the institution. Her name is Jenny Flegel-George. And so I'd like to provide that link, and then you can take a look at all the actions that we have done at the institution. And if you feel that there are others that we should be a little bit more proactive on, both Anita and I are open to hearing about this. Anita, I'm going to move to another question. The question is about the imposter syndrome. So as a woman in mathematics, have you ever experienced imposter syndrome? And if yes, how did you overcome it, or how did you deal with it?
All the time. I just stopped caring. In a little bit more detail. So Charmaine, you know what the Putnam math competition is. Okay, so for those in the audience who may not have heard of it, so the Putnam Competition is an annual math competition for undergrads enrolled in the United States or Canada. So this exam is crazy hard. The university only send their very best to win. Okay, so you can ask me, when I was an undergrad at Duke, did I compete in the Putnam for Duke? Well, I didn't. Well, probably because maybe I wasn't good enough, right? Okay, so imposter syndrome. So imagine you were me, you're Anita, you were 18 and you walk into your first calculus class, right? So the class is going well and you're thinking, oh, all right, you can do this. You know, you like math, so maybe you can be a math major. Then some of these really smart kids who do compete in the Putnam exam started asking questions, really, really, really hard questions. So what makes it worse is the other one answer those questions, and which you don't even understand what it's about. So you're like, okay, that's what a math major looks like, right? And I don't look like that. And you may be more likely to get discouraged if you're a woman. So what does it take to be successful, right? Successful in math or successful in general? I mean, are you real or are you imposter? Do you have to be like somebody else, like this, student that compete in the Putnam exam? So I'm going to argue that there are multiple ways to be successful, and it's all good. So to do well in that particular math exam, you need to be able to find a trap door in under 5 minutes. And guess what? Not all of us are good at that. I'm definitely no good at that. So when I'm given a problem, I think about it really, really hard. I think about it all the time. So maybe after 2 weeks, the solution will come to me, right? When I'm maybe shoveling snow off the driveway, which I actually did 2 days ago, as we know. In mid-May, we had snow. It's crazy, right? Weather. So I won't do well in this particular exam, but I would also argue that you can go pretty far in life by working hard and being persistent. So you are as good as the other person in terms of achievement. So when I see a young woman having doubts about her ability, thinking that she's an imposter, I often want to tell her this. So there are very often times that we feel intimidated or inadequate. And in fact, sometimes I'm full of myself, which I am, but I'm actually quite familiar with these feelings of inadequacy. But I have learned to say this. I've learned to say, hey, Charmaine, you're really great at this. Good for you. But guess what? I'm good at this other thing. So isn't that wonderful for both of us? So the point is there are more than one way to be successful, but young people often don't realize that. And I think it's our job to help them understand.
Mm-hmm. And you know what, Nita, when you're charting new territory, as all of the women who are attending this particular conference and all the women who are in mathematics at this time on this planet are doing, then you've grown up. A lot of us have grown up with a different kind of culture. So there's always been this background social pressure that we're not even aware of, that starts to instill you can't do this attitude, and we have to overcome that. And then as we grow in our careers, then our brain starts to kick in and do the same thing for us, and we have to overcome that again. So it's not necessarily that it's something that our brain has dreamt up and put in front of us. It may be something that has come through our culture all the way through the development of girls in society. So there's a lot that's wrapped in there in this imposter culture, and you just gotta ignore it. Tell your brain to go away and let you do what you like doing and just get on with life. Stop telling bad things to you. Mm-hmm. I wonder if you could talk about how one of the things that helps with the imposter syndrome, by the way, is related to the next question. Once you get into something that you like, all of these doubts and questions go away because you're just having fun and enjoying what you're doing, and you're seeing that you're making a difference, and then it becomes all about the work, not so much about you. So the next question is about, how do you know what area of research you wanted to focus on? How did you know that for your particular career?
So when I was growing up, I was told that I need to be a medical doctor. I think maybe it's an Asian thing, right? So I'm going to grow up and be a doctor. And I wanted to do that, I think, until, as I mentioned, in college. So I went to college. I know I want to understand how things work. I want to understand, the mystery of the universe. So I thought, oh, physics, that's what it is. So I started being a physics major at Duke. And I realized that I cannot do labs at all. Okay, so like I said, anything I touch tend to break somehow. Even the simplest, like, physics experiment where, you have an incline and you roll something down and you tap, 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 and you're supposed to find the acceleration, the gravitational constant is supposed to be what, 9.8? Mine is like 3. Okay, I don't know how it came out to be 3. I have no idea why that is. I can read and I follow instruction and it always turned out wrong. So what do you do? Well, you partner with somebody who can do the experiment. You keep your hands off of that and you don't touch it and you write the analysis. So I'm always the one, who write up the results and do the analysis. I can do that, no problem. But then at some point, you can believe in yourself, but there are times where you have to realize this is not for you. When you cannot do lab, you simply cannot, go all that far in physics. So I switched over to computer science because it still allows me to figure how things work, but virtually, right? So, if you make a mistake, it's okay. If there is no sound, there is no fire, and no one knows, and, you just have to quietly debug it. So that was fun. So I got into computer science. And then once I got into grad school, I want to use my skill, which is computing and actually mathematics, which I refused to acknowledge at the time, but yeah, math and computer, to help understand how that works. I wanted to do something in physics, so I thought, oh, weather is nice. It's a big system, it's complicated. I like complication. So I did modeling of numerical weather system. And then afterwards, I realized it's not really weather that I like. I like things that flow. So I started doing biology because, there's blood flow, anything that flow is cool. So I started doing biology. It's a lot of fun because I get to collaborate with all kinds of people, right? I don't just work with mathematicians. Actually, I have a very, very long list of collaborators because I like making friends, and almost like very, very few of them are fellow applied mathematicians. I like working with like clinicians, physiologists, biologists, chemists, like engineers, biochemical engineers, all kinds of people, and you learn different things from them. So what was the question? I forgot. Oh yeah, how I got into this? I got into this because, it allows me to understand things. It allows me to interact with people, and it allows me to work with all kinds of really, really interesting people that I can learn a lot from them.
So we've got a couple of questions, and I think I'm going to do a little bit of picking now because we're coming near to the end. So let's take one about environment. So, the general question is about, creating a culture for a supportive work environment. And then the more specific side of it is, have you found that supporting other women at work can cause some men to get upset with you? I wondered if you could comment on both sides about that particular question, and more generally about how we change culture. How do we create a supportive working environment?
Okay, so I will address whether I get people upset first. So I guess bottom line is, I've learned this, the only way not to have people upset at you at all is not to do anything, right? So if you have I won't say enemy, but nobody like, whoa, okay. Nobody, if you have no enemy, that probably because you haven't done anything in your life. That said, when I was younger, I really don't worry about, what people think of me. Now that I'm older, I realize, well, if you have too many enemies, it's not good for your career. It's not good for what you want to get done. So I support other women. I promote equity and diversity. I understand that that doesn't always, it is not everybody's priority. So I do it in as diplomatic a way as possible. I try to support other women. I try to help them get what they want with a smile. So I'm nice about it. If I take something away from somebody else, I see what I can do for them, like a man. If not, you do it as nice as possible. If they still get upset, well, you ask yourself, have you done something that you believe in? Is this the right thing to do? If it is truly the right thing to do, and you have tried your best not to step on other people's toes, and they still get upset anyway, oh, well, that's just too bad. If you're unhappy about it, have yourself a chocolate and get over it. So that's my attitude. So what's the next question? Oh, how to support other women? I think having a network is important, right? Because all of us, as we talked about, we have imposter syndrome. It's good to talk to other people, right? So okay, I don't feel like I'm good at this. But once you realize you're not the only one thinking that, it really helps. Like if you're on social media, Facebook or whatever it is that you're on, right? Everybody seems to have the most fabulous life, right? They have they have beautiful picture. They're always going on vacation. Maybe not now with the pandemic, but like everybody's having a good time. Is it true? Probably not, right? So if you are worried about whether you are good enough for this, maybe you're not the only one having doubt. Knowing that would be good, and being able to learn from others' experience has always been quite helpful to me as well.
Mm-hmm. I think that standing up for principles, especially when there are few people around and you're working with somebody who is in a disadvantage, either because they are a young faculty member or a student, I think that's really important, especially for senior women in serving as excellent role models. But I'd also say, Anita, on the other side of that coin, it's really important to listen. If we don't listen to what individuals are saying, then we actually won't know how to address changing the culture. So I agree with you completely in how you approach the situation. If you are, sometimes when you open up and you chat with someone who is having a difficulty understanding why this focus is important, you realize that there's something else that's at play there, and that addressing that something else makes it easier for the individual to leapfrog the barrier that they see in devoting time and energy into supporting women, into, yes, this is okay because you've helped me solve my problem here, and that I realize now that it's a completely different problem than what's been trying to then that can arise from what you're trying to achieve by supporting women in your department or faculty. So principles are important, but listening is also important, because listening gives you the avenue by which you can change culture. So one quick question to end with, and then we need to turn it over. So the response really quick, but I wondered what's really exciting for you at this point?
What's really exciting for me in terms of a career-wise?
Your career, yes.
Actually, it's actually promoting equity. So research is interesting. I love it. I don't know. I mean, you're asking me to choose from all these wonderful things. Right? I love my job. I love the research that I do. I love working with my research group. I get up really early, like every day. But I get up happy because I get to do what I love. I cannot really choose. So, I love working, on equity initiative with you. I love serving on this panel. It's 7:30. Most people think this is crazy early, but you do something that you love, that's great. I don't care what hour it is. the research is fun. I got to learn new things. I got to figure out how things work. Modeling COVID is good too, although, I find it a little sad because, other people are suffering, but, you get to do something that helps. You get to do what you believe in. So that is truly exciting to me. But, besides work, I love my kids who are sleeping right now. I love hanging out with them. They gave me a big, gigantic hug, drew me a wonderful Mother's Day, card, actually swept the floor that day so I don't have to. I still cook because, I don't know why I just did it. It's a good thing to, it's like Mother's Day, like they do something for me, I do something for them. So everything's good.
Thank you, Anita. Wonderful answer. It sounds like making impact, right? Making impact in everything that you do. That sounds like that's what's exciting for you. I'm going to turn it over to Katie now. Thanks again, Anita, for joining us this morning. And I'll let Katie give some closing remarks.
Perfect. Well, that was really wonderful. I wanted to thank both of you so much for your time this morning. I know I got a lot out of this conversation, so I hope that everyone online that was able to join us also got some good little tidbits of information out of this session. Thank you again for joining us, and we hope you're able to join us for our next session, which is Women Changing the World, a conversation on the power of doing good.